Here we have the 2012 paper 2. This is question 13, junior cert higher level, and this is a question on trigonometry. So the question says two vertical poles A and B, each of height h, are standing on opposite sides of a level ground. So they are 24 meters apart. So there is two poles A and B. So this is A, and they're both of height h, so they're both the same height. And it's a level ground here, and they're 24 meters apart, so 24, that's what this stands for. And the point P is on the road is directly between the two poles, so it's a distance x from this pole A. And then the angle of elevation, so the angle of elevation, say if we have a line here, the angle of elevation is going to be the angle looking up in regards to horizontal. So say this would be the angle of elevation with our horizontal, but say if we wanted the angle of depression, well, that would be the angle looking down from the horizontal. So that they've already put in the angle of elevation, so we don't even have to label it ourselves. So the angle of elevation from P to the top of the pole is 60. So they've drawn in 60 here, and we're also told that this is 30 degrees. And we're told to write h in terms of x. So if you want to write h in terms of x, well, what we might have to do is use our sin, cos and tan. So firstly, I'm going to just deal with this triangle here. So if I'm going to deal with this triangle, I have 60 degrees, this is a right angle, this is h, and this is x. So if I deal with my sin, cos and tans, because I can't use Pythagoras because I don't have my three sides, I only have one side so Pythagoras won't really work in this part. So I'm going to have to use sin, cos and tan. So my h in this case is my opposite, my x is my adjacent. So if I look for a ratio that has opposite and adjacent, so so tan actually, so the tan is the opposite over the adjacent. Tan is equal to the opposite over the adjacent. So the tan of 60, which is my angle, is equal to the opposite, which is h, over the adjacent, which is x. And I was asked to write h in terms of x, so they just want h is equal to something in terms of x. So what I can do is multiply both sides by x to get rid of my fraction, and then it'll be, so this will cancel with that, and then it'll be x tan 60 is equal to h. And I'll just work out what tan 60 is and see if it gives me like a really long recurring decimal. So it actually works out nicely, it gives me root 2. So, sorry, root 3. It gives me root 3 there. So it'll be x root 3 is equal to h. So that's going to be h in terms of x. And then the next part is, so I'm just going to write down what I got. So from part A, I got that h is equal to x root 3. Because sometimes what we do in one part is going to be useful for what we do in the next part. It's kind of like a hint that we need to use this in the next part of the question. And we still have our diagram here, and from P the angle of elevation to the top of the pole is 30 degrees. So I'm just going to turn this over so we can see it clearly. So from P, so the angle of elevation to the top of pole B is 30 degrees, so they've drawn in 30 degrees, and then they say find h, the height of the two poles. So firstly, I'm after getting that h is equal to x root 3. So the only information I'd be able to deal with, say, in this triangle is, well, I can draw out this triangle here. And I want to find the height of the two poles. So I know that the total length of this is 24. So if this is x, well, then the length of this bit is going to be 24 take x, because I'm going to need to kind of have, I want to stick with the same variables so I don't add too many different unknowns into my equation. So this bit here is 24 take x. So I'm going to try to find the height h. Well, I already have h in terms of x in one part, so maybe if I get h in terms of x on another part. So that's 24. Take x. So say if I draw out this triangle here, I can do the exact same as I did in the last part, and then we'll have two values of h in terms of x, and we should be able to let them equal. So 24 take x, this is h, this is my angle. So if I want to get, I have my my adjacent and my opposite. So the tan of an angle is the opposite over the adjacent. So the tan of 30 is equal to the opposite, which is h, over the adjacent, which is 24 minus x. So what I'm going to have to do here is I'm going to have to multiply both sides by everything that's on the bottom. So I'm going to have to multiply both sides by 24 minus x, and multiply this side by 24 minus x. So then these will cancel because it's the exact same thing on the top and the bottom. So 24 minus x, and that's all multiplied by tan 30, and then that's equal to h. And now I'm just going to see if I can work out what tan 30 actually is, say if it works out kind of neatly. So tan 30, and I get root 3 over 3. So 24 minus x, and that's all multiplied by root 3 over 3 is equal to h. Well, I could multiply that 24 by this, and then x by this, and then I'll have x in terms of h. So 24 by root 3 over 3, and then minus x by root 3 over 3, and that's equal to h. And I could just simplify that a little bit more by 24 divided by 3 gives me 8, so that'll be 8 root 3 minus x root 3 over 3 is equal to h. So now I have two equations in terms of h. So this is my first equation in terms of h, and so this is my second equation, and this here is my first equation. So I'm just going to write out each of them. So I got from the first part, I got that h is equal to x root 3. So h is equal to x root 3, and from the second part I got that this part here. So I got h is equal to 8 root 3 minus x root 3 over 3. But h is equal to h because we told they're both in h, so I can let them equal. So I'm going to let x root 3 is equal to 8 root 3 minus x root 3 over 3. So the first thing I want to do in this to solve for, the first thing, I know I want to get h overall, but I'm going to have to get x first, and then I can just sub the value for x back into, say, one of my equations, and then I'll get h. So firstly, I'm going to have to get what my x is. So in order to do that, what I'm going to have to do is say I want to get rid of my fraction, so I might multiply both sides by 3, multiply everything by 3. So this by 3, this by 3, and then this by 3. So now I'm multiplying and dividing by 3, so these will cancel. So then this will be, so that's multiplied by 3, so 3x root 3, and then is equal to 8 by 3 gives me 24 root 3, and then minus x, and then root 3. So now what I can do is, so I can bring my 3x. So what I can do now is, because I'm multiplying absolutely everything by root 3, what I can do is I can divide everything by root 3, divide by root 3, divide by root 3. So then this cancels, and this cancels. So I'm left with 3x is equal to 24 minus x. So if I want to get what, I want to get x on one side, numbers on the other. So 3x plus x is equal to 24. So 4x gives me 24. So if I want to get what x is, I divide both sides by 4. So x is going to be equal to 6. But I know that h is equal to, I can plug x back into this one or this one. It might just be handier to plug it back into the first one. So h is x root 3, but I got that x was 6. So h is going to be 6 root 3. So that was a little bit lengthy for that question, but once we get through it, it was okay. Once we got through it, it was okay. So that is our answer for that.